Hello everyone, to this lecture we will talk about the matrix operations. We'll start by the addition. So if we have two matrices A and B, so we can compute A plus B if these two matrices have the same size, which is the case here. So this matrix has 3 rows and 2 columns, so it is 3 by 2 matrix, and also this matrix here is 3 by 2 matrix. So we can compute A plus B, which will be equals here this entry plus this entry here, 1 plus 1, it is 2, and 2 plus 2, which is 4, and 3 plus 3, which is 6, and 4 plus 4, which is 8, and 5 plus 0, which is 5, and 6 plus 1, which is 7. So this is how we compute the sum of two matrices. So they must have the same size. And the same also for the subtraction. So if we have two matrices, we can take also the same matrix here, A and B. So there A minus B will be equals to 1 minus 1, which is 0, 2 minus 2, which is 0, 3 minus 3, which is 0 also, and 4 minus 4 also is 0, and 5 minus 0 is 5, and 6 minus 1, which is 5 too. So this is how we compute the subtraction of two matrices. They also must have the same size. So to be able to do subtraction for two matrices, they must have the same size. We can multiply also a matrix by a scalar, for example Ka. So in this case here, if we take K equals 2, for example, 2 times this matrix will be here 1, 2, 3, 4, 5, 6. So this is K times A, which will be 2 times 1, which is 2, and 2 times 2, which is 4, and 2 times 3, which is 6, 2 times 4, which is 8, and 2 times 5, which is 10, and 2 times 6, which is 12. So this is the scalar multiplication of a matrix by a scalar K equals 2. The matrix multiplication, or the multiplication of a matrix by another, is different, and there is a method to compute them. So first we need to check that the matrix multiplication is defined, so these two matrices can be multiplied. The first thing is to check if the number of rows of, for example, if we have a matrix A and a matrix, and we want to multiply it by matrix B, so the number of columns of this matrix, which is n, must equals the number of rows of this matrix. So we don't care about the number here, for as can be any number, for example m, and here can be any number, for example r. So but these two numbers must have the same. For example, 3 by 2 matrix can multiply it with 2 by 5 matrix. For us, these two numbers isn't important. The most important are these two numbers, which must be equals. So this is how we compute or the first check if the matrix multiplication is defined or not. And the matrix isn't commutative, so AB not always equals BA. Sometimes AB is defined and BA doesn't. Sometimes it is defined but it's different from AB, and sometimes it is even not defined. In some cases it can be equals, so AB it can be equals to BA, but this is rare cases, and the safe thing is to say that AB is different from BA. And to compute the product of two matrices, for example, I have an example here of two matrices AB. So this matrix A, which have 3 rows and 2 columns, so it is 3 by 2 matrix, and this matrix here B have 2 rows, so it is 2 by 4 columns, so it is 2 by 4, and we can get A, B, because here we have 2 and 2. The result matrix, we will call it, for example, C. So C equals AB. This matrix will have size 3 times 4. So this matrix will be 3 by 4 because these 2 and 2 will disappear. So in this case here, this n will disappear with the n, and we'll get the result will be m by r. So this is the result matrix. And I will show you how to get this matrix, how to compute this matrix. So let me erase this here. So matrix AB will be equals matrix A 1 2 3 4 5 6 times a matrix B, which is 0 5 2 2 1 3 0 4. So the product here will be equals the matrix with, here we have, as we have 3 by 2 and here 2 by 4, so the result matrix will be 3 by 4. These two will go with these two. So this matrix will have 3 rows, so it will have 3 rows and 4 columns. So it will be 4 columns, value here and entry here and here and here and here. So this is the result matrix, which have 3 rows and 4 columns. How to get this entry here? So to get this entry here, which is at the first, which is at 1 1, so we will get the first row of the left hand side matrix and the first column of the right hand side matrix, and we will multiply this entry with this one and this entry with this one and get the summation, which will be at this value. So this A11 will be equals to 1 times 0, so this row here with this column, so 1 times 0 plus 2 times 1, so it is 1 times 0 plus 2 times 1, which is equals to here 0 2, so it is 2. And the entry here is the first row here times the second column here, so it is at the first row and the second column, so we will get it by multiplication of this row by this column. So it will be this, let me call it, it's called A1 because it is the first row, 2, so this A, which is equals 1 times 5, so it is 1 times 5, it is 5, 2 times 1 times 5 is 5, 2 times 3 is 6, so 5 plus 6, which is equals 11. So it is 11, right here, 11. And the value here is this first row times this third column. So it will be 1 times 2 plus 2 times 0, which is this will be 0, and this 1 times 2 is 2, so it will be 2. And this entry here will be the first row with the third column, so it will be 1 times 2 plus 2 times 4, which is 8, so 8 plus 2, which is 10. And so for getting this entry here, we will multiply this row because this is the second row and the first column, so this row with this column. So we will, let me use another color. So this row here with this column, so it will be 3 times 0, so this value here is 1 to be clear, so 3 times 0 is 0, 4 times 1 is 4, so it will be 4, and the value here in the second column is, and the second row is the second row times the second column, which is 3 times 5 is 15, so let me write it here, A11 A22, sorry, which is equals 3 times 5, which is 15, plus 4 times 3, so this is with this, so 4 times 3, which is 12, so this value is 27, so this value is 27. And the third entry here is this row with this third column, so we'll get 3 times 2, which is 6, and 4 plus 4 times 0, and it is 0, so 3 times 2, which is 6, so this value is 6. And for the last entry in the row, so in this row is 4 times this 2, 4, so it is 3 times 2, which is 6, plus 4 times 4, which is 16, so 16 plus 6, which is 22. And to get the last row here, so last row here, for this entry we will multiply this row here with this column, so I can use also another color, so let me color here, so this one will multiply with this one also, and it will be 5 times 0 plus 6 times 1, which is 6, so it will be 6. And we'll also multiply this with this, so it will be 5 times 5, which is 25, plus 6 times 3, which is 18, so this equals 43, so it will be 43 here. And the value here is the product of this row with this column, so it is 5 times 2, 6 times 0, which is 0, so 5 times 2, which is 10. And the last one here is this row with this column, which is 5 times 2 is 10, 6 times 4, which is 10, plus 6 times 4, which is 24, which is equals 34, so this is 34. So the matrix here AB is equals 2, 11, 2, 10, 4, 27, 6, 22, 6, 43, 10, 34. This is the result matrix, which is a 3 by 4 matrix. However, the matrix here BA is not defined, because B here is 2, 4, so it is 2, 4, and A here is this is B, and A here is 3 times 2, so 3 by 2. So these two terms don't match, so we can't compute BA, so it is undefined, so we can't compute BA.